Hello there, our wonderful and esteemed viewers on this favorite mathematics YouTube channel, Mathematics by Abu Zainab. That channel is specially created for you and I to demystify mathematics and tackle the age-long phobia associated with this all-important subject, one topic at a time. Today's class promises to be exciting, interesting, and most importantly, fun as usual. Today's class is going to be a continuation of our series on quadratic equations with the further mathematics perspective or flavor. In the last lessons, we looked at forming quadratic equations with given roots or given sums and products of roots respectively. And particularly, I emphasized in the last class that there's importance for you as a candidate to distinguish when we have the first case or from the second case. The first case being that you are given the root, the raw root. All you need to do is to sum the root given and the product, and then substituting in an already customized equation, which is x squared minus sum of the product from of the roots rather times x plus product of the roots equals 0, of course. The other case is whereby you are given the sum and the product already. All you need to do then is not to sum or multiply again, but by just merely inserting the finished product into the customized equation again. If you have any doubt whatsoever, please feel free to revisit the video and have fun. Today we take the class a notch higher by looking deeper into the aspect of roots of quadratic equations, more specifically using the sum and product, the alpha plus beta and alpha beta, as derived in the very first lesson of this series. And then we explain that alpha plus beta is simply minus b over a, and alpha beta is c over a. So our entire work today is going to be premised on those two concepts of sum and product. So I enjoy you to sit back and right along, let's have fun. The question before us today is that if alpha and beta are the roots of the quadratic equation 2x squared plus 3x equals to 0, find the values of the following. It's quite a lot, but it's very, very interesting. The very first challenge for us is to try to rewrite this quadratic equation in the standard form. Remember the standard form, everything must be equal to 0. Hence, I'm going to have 2x squared plus 3x minus 6 equals 0. That's the standard form. From where my a is 2, my b is 3, and my c is minus 6. This is very, very crucial. Once you get any of these wrong, most likely your work will be wrong. Now, let's take the question 1. Alpha plus beta is minus b over a. So, minus b is 3, a is 2. And that's all. It's as simple as that, straightforward. On the other hand, alpha beta, which is question 2, is c over a. And my c is what? Minus 6. And a is 2. Hence, we have minus 3 as alpha beta. Then question 3. We are to find the value of 1 over alpha plus 1 over beta. As you can see clearly here, this is not a direct sum and product. However, you need to simplify further. So we have alpha plus alpha beta as a LCM. So alpha and alpha beta, we have beta times 1 beta plus beta and alpha beta, we have alpha times 1 alpha. Recall that beta plus alpha is the same as alpha plus beta by the commutative property in algebra. Hence, I'm going to have alpha plus beta over alpha beta. So interestingly, we have been able to express this sum as a mixture of sum and product. So the sum here is minus 3 over 2. So we have minus 3 over 2 divided by minus 3, which is alpha beta, minus 3 over 1. So this can be simplified further as minus 3 over 2 times, you can either write minus 1 over 3 or 1 over minus 3 is the same thing. Then everything reduces to just 1 over 2. Those are the first three. I believe at this pace you are finding it quite interesting. So let's move on to the next numbers. It's very important to take to heart that all through we'll be needing the sum and product. So we may need to write that somewhere. Alpha plus beta is minus 3 over 2. Alpha beta is minus 3. We'll be needing all these values all throughout the work. So now question number 4. We've got alpha squared plus beta squared. Now, don't mistake this to be alpha plus beta squared only. No, this is sum of squares, whereas this is square of sum. So this actually equals, in addition to alpha plus beta squared, we must have minus 2 alpha beta. Then again, you can see that we have successfully expressed this as sum and product. Different variants of sum and product. So alpha plus beta is minus 3 over 2 all squared. The minus 2 alpha beta is minus 3. So you're going to have what here? 9 over 4 plus 6 over 1. When you find the LCM there, you're going to have 9 plus 24, which is 33 over 4. Or 8 whole number 1 over 4. Then number 5, we have now alpha over beta plus beta over alpha. Again here, this is not clearly sum and product. So we have to simplify for that. We have alpha beta as LCM. Beta in alpha beta, you have alpha times alpha, alpha squared, plus alpha in alpha beta, you have beta times beta, you have beta squared. Interestingly, we've just solved alpha squared plus beta squared here, which we're going to slot in as simply 33 over 4. That's the numerator. Divided by alpha beta is what? Minus 3 from there. Then we have 33 over 4 times 1 over minus 3. Remember, I said it's either you choose to put your minus as numerator or denominator. So we're going to have minus 11 over 4. Minus 11. That is minus 3 in 33 is minus 11. And of course, the final answer is going to be minus 2 whole number 3 over 4. That again is the answer there. Okay, if that is clear, as I expect it to be, let's move further. To question number 6. Question number 6 is quite straightforward, very, very straightforward indeed. Remember, whatever you do, you must express in terms of sum and or products. This is clearly not sum and products. So we have what a factorize first, alpha beta, then alpha plus beta after factorizing. So alpha beta is minus 3 and alpha plus beta is minus 3 over 2. And this gives us 9 over 2 or 4 and a half. And that is number 6. Very straightforward indeed. Now, number 7 requires a bit of algebra, deep algebra. Alpha minus beta. Clearly, alpha minus beta is not in the established rules. So you have to extract sum and product therefrom. Alpha minus beta is actually the square root of alpha plus beta all squared minus 4 alpha beta. That is the identity for that. So we go further by having alpha plus beta minus 3 over 2 all squared minus 4 times alpha beta is minus 3. So this is actually 9 over 4 plus 12 over 1. So there we're going to have root of, when you take the LCM there, you have 4. That's 9 plus 48. And that's actually root 57 over 4 or root 57 over 2. Look at that. I've done the root of sort there. So the root of numerator, root of 4, denominator remains that. And that's the answer to number 7. So following number 7 closely, we have number 8, which is alpha squared minus beta squared. So this is basically difference of two squares. Remember, we have then alpha plus beta, then alpha minus beta. So we have C expressed as sum, even though there's no product here. But interestingly, we have our value for alpha minus beta from the last example. So alpha plus beta is minus 3 over 2. And so alpha plus beta is minus 3 over 2. And alpha minus beta is just this. We have root 57 over 2. And that's actually minus 3 root 57 over 4 as alpha minus beta. And that leaves us with the very, very last question there. This number 9. Yeah, the last question there. We've got alpha cube plus beta cube. Again here, this requires a special identity. This is this, minus 3 alpha beta bracket alpha plus beta. So all we need to do is to slot in the values. So alpha plus beta all cube, we have minus 3 over 2 all cube minus 3. Alpha beta is minus 3. Alpha plus beta again, minus 3 over 2. So by simplifying, alpha minus 3 over 2 cube, that is minus 27 over 8. So we have this minus 3 times minus 3 times minus 3 is still minus 27 over 2. So when we simplify this, the LCM is 8, of course. That's minus 27. Minus 2 in 8 is 4. 4 times 27 is 108. 108. And when you do that, we're going to have minus 135 over 8. And that is the solution to the 9 questions on this aspect of quadratic equations. You are given the roots. You're asked to evaluate some other algebraic identities. The question is very, very explicit, I believe, and quite intense. So, in as much as you might find it challenging at the onset, that's perfectly understandable. All you need to do is to look carefully, review over and over, and lay your hand on some questions. If you find today's class as interesting as I expect it to be, and fun as I did here, please do well to subscribe, share, like, and ultimately, most importantly, endeavor to tune on your button so that when our next video is uploaded, you'll be among the first to know. Thanks as always for viewing and stay blessed.